Hi, it's time for another math easy solution. Here to discuss an example video basically on the mean value theorem. I went over this a while ago, so now I want to illustrate it with an example. And you can watch my earlier video on introduction and some other examples on mean value theorem in the video links below. So basically, before I get to the example, I want to go quickly recap the mean value theorem. Basically, it states if you have y equals f of x and the following is true, f is continuous on the closed interval a and b. Closed just means that at a and b that the fx exists, and f is differentiable on open interval a and b. This just means it doesn't have to be differentiable at a and b, but it has to exist, the f of it, but not the derivative of it does not have to exist at these points. Then basically there is a number c in this open interval a and b such that f of c is equal to f of b minus f of a all divided by b minus a, and this is basically a rise over run. And if you were to draw it graphically, if you have a function, let's say like here from a to b, there's f of a, there's f of b, there's these values, it's continuous and differentiable in between, then there has to be this c value, which is, let's say, because this is, remember, this is just a slope from this point to this point, so this one is over here, so this slope is f of c. If I were to draw this slope, and this is just rise over run, and that's this is going to be f of b minus f of a, and then this difference here is just b minus a, and this is just f of b minus f of a. So this is just rise over run, so it's just saying there has to be a value c, and as you can see graphically there is, so anywhere in between it, so there's a slope exactly the same, it's parallel to it, and this would be f prime of c, and c would be somewhere over here. So anyways, that's just a quick recap. You can see more on this in the video link below. I go in detail on the basic mean value theorem. So the example I want to go over is this one here. It states, suppose that f of 0 equals to -3 and f prime of x is less than or equal to 5 for all values of x. Now the question states, how large can f of 2 possibly be? So first of all, we're given the derivative exists and it's differentiable at all points, because we know that it's always going to be less than or equal to 0, so it does exist everywhere. So we do have basically our our 1 and 2, both of these conditions met, because this, if it's differentiable everywhere, it's also continuous. You can see more on that in the video link below. And so basically the way to solving this is, yeah, it's always first to graph it out or draw it out to makes it easier to solve. So let's just write what we know. So f of 0 is at -3 right here, and now f of x is always going to be less than or equal to 5, and now saying what is f of 2 here. So if this is 2, so it can be, remember it's continuous and differentiable, so it could be something like this, or it can go somewhere like, let's say it can connect over here, etc., or it can go somewhere over here. So you don't know what this value is. It's going to be here, 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 but so what we're asking for the maximum value here. So we know if we just apply the mean value theorem, we could basically just plug this in, so we could write down this as a inequality to solve for the maximum. What I mean by that is, well, there has to be a c value. Yeah, there has to be a c value in between here such that f of c is equal to f of b minus f of a all divided by f by b minus a. This is by the mean value theorem, so it has to be in there. And we know basically this derivative is any number in between, and this has to be, well, less than or equal to 5. So we have to write less than equal to 5 right here. So now we could basically rearrange this. Yeah, but before we arrange it, let's just plug in the values that we know. So we're looking for f of 2, so plug, that's just b. So this is going to be our b, and our a is going to be equal to 0. So a equals 0. That's the initial point right there. So we'll go f of 2 minus, this is going to be, well, -3, which is f of 0, and all divided by 2 minus 0. So 2 minus 0 is 0, so this is going to be less than or equal to 5 right here. And now this is, if we just times this part out on both sides, we're going to get f of 2, this is going to be +3, is less than or equal to 5 times by 2. So I multiply the 2 out, basically just do this on both sides to get this rid of it. So now we get something like this, and this is equal to 10. Now we can subtract a 3 out, so we get f of 2 is less than or equal to, make it over there, 7, or 10 minus 3. So basically our answer is this one right over here. So f of 2 has to be less than equal to 7 right here, and so that is the highest value it can be, so it should be somewhere over here. And another way you could even solve it, yeah, this is basically, you could use it as an equation of a line. So there's our f of 2 right here, and that's just going to be f of 2, and this equals to 7 right here. And what this is saying is going to be, basically the maximum is going to be a straight line like this across it, and you're going to have, actually I just drew it red just to show this. So basically this is just saying the maximum is if every single value was 5 of the derivative, then you're just going to get a straight line like this, and it's going to be somewhere over there. And yeah, basically you could use mean value theorem to solve that. Anyways, that's pretty much all for today. Hopefully you learned from this video how to use this mean value theorem, which is pretty straightforward. When you draw it out, it has to be true. Anyways, you can download these exact notes in the link below, and thanks for watching, and stay tuned for another Math Easy solution.